Hello guys, welcome back to Infinite Insight Geometry, lesson 4.3, Transversal Proofs. Alright, let's begin. So, in the last lesson, 4.2, we introduced 5 new theorems. These are all transversal congruence theorems. We have the alternate interior angles, same side interior angles, alternate exterior angles, same side exterior angles, and corresponding angles. And you might notice that if we have a singular transversal with parallel lines, then we can make connections between all of these angles. So let me go over the very specific proof that enables us to prove these theorems, more specifically the first 4 theorems, using the corresponding angles theorem. The corresponding angles of a transversal are congruent, which we know is true. If angle 1 is 60 degrees and lines B and C are parallel, then find the measures of angles 2 and through 8. So I'm just giving an arbitrary measure to angle 1 here. But please note that since angle 1 is 60 degrees, then any angles from 2 to 8 that are 60 degrees will be congruent to angle 1 because they have the same measures, they have the same size, and are therefore congruent. And this will be a theme throughout the rest of this course. If you see 2 lines, triangles, angles, squares, or circles that have the same size and shape, no matter their configuration, they will be congruent. So let's get into the proof. So the 2-column proof goes as follows. We have the measure of angle 1 is 60 degrees and lines B and C are parallel. That's given. And then we can see that line A intersects lines B and C, meaning that they make a lot of vertical angles. So we're going to list down all of the congruent vertical angles right now. Angle 1 and angle 4 are congruent, angle 2 and angle 3 are congruent, angle 5 and angle 8 are congruent, and angle 6 and angle 7 are congruent. If you ever need help trying to prove vertical angles congruent, or making sure that 2 angles are actually vertical angles, then you can just pick the angle that you want to prove that is a vertical angle to another angle and go all the way around. So like if we have angle 6, for example, we would go all the way around 180 degrees and then we would end up at angle 7. So that's why angle 6 and angle 7 are vertical angles. So now that we've proved that everything are vertical angles, we can go on with the proof. Angle 1 and angle 2 form a linear pair, and we can see this because line A makes a ray sticking out of line B. That makes angle 1 and angle 2 vertical angles. I mean a linear pair, meaning that they are side by side, meaning that they are supplementary by the linear pair theorem. So, since angle 1 and angle 2 are supplementary, by using the definition of supplementary angles and the addition angle addition postulate, we can say that the measure of angle 1 plus the measure of angle 2 is 180 degrees. Substitute the measure of angle 1 for 60 degrees because that's what we're given, and we have the measure of angle 2 equals 120 degrees. So that's the measure of angle 2. That's already one part of the proof done. Now we have to find the measures of the rest of the 6 angles, and fortunately for us, this is very easy. Since the measure of angle 1 is equal to the measure of angle 4, and the measure of angle 2 is equal to the measure of angle 3 by the definition of congruency. The definition of congruency will be very important here in this transversal proof because everything is congruent to everything else, meaning that if we want to prove them they have the same size, we will have to use the definition of congruency a lot. So the definition of congruency states that the measure of angle 1 is equal to the measure of angle 4, and the measure of angle 2 is equal to the measure of angle 3. So by substitution, the measure of angle 4 is 60 degrees, and the measure of angle 3 is 120 degrees. But what about the other parts of since right now we've just been proving the measures of A and B. So what about the angles of lines A and C? Well, that's a different story, and we're going to have to use the corresponding angles theorem. Angle 1 and angle 5 are congruent, and angle 2 and angle 6 are congruent because they're corresponding angles in a parallel transversal. Meaning that we can substitute to get that the measure of angle 5 is 60 degrees and the measure of angle 6 is 120 degrees. And then invoke the definition of congruency again to leave us with the measure of angle 8 is 60 degrees and the measure of angle 7 is 120 degrees. Now notice, these 2-degree measures, 60 degrees and 120 degrees, they show up everywhere. And even if you did this with another angle measure, like for example, you started off with 45 degrees for the measure of angle 1, you will also find out that the measures of angle 4, 5, and 8, no matter what the measure of angle 1 is, assuming that is in between 0 to 180 degrees, it will also be the same. They are always congruent. Angle 1, angle 4, angle 5, and angle 8. And that's where we get all of these different theorems. But because angle 1 and angle 4 are congruent, those are the vertical angles. Since angle 1 and angle 5 are congruent, that means that they are corresponding angles. And since angle 1 and angle 8 are congruent, that proves the alternate exterior angles theorem. And if we look at angles 4 and 5, they would also prove the alternate interior angles theorem. And the same side interior angles and the same side exterior angles are just branches of these congruency theorems. So now that we know everything that there is to know about transversals, I want you to stop and think for a moment, because transversals are also going to be pretty important, as well as parallel lines. There will be many of times that we will have to invoke the alternate interior or exterior angles in our proofs. So this is just the groundwork. This is how it works before we use it on other lessons. And that'll be all for today's lesson. If you liked the video, please like and subscribe. I have my email down below if you have any questions, and I'll see you all next time.